In continuation to the types of solution, today we are going to study the classification of solution, which is based on the concentration or amount of solute dissolved. So, on the basis of concentration of solution, we can classify this into dilute solution. What is the meaning of dilute solution? Solution in which small amount of solute is dissolved in large amount of solvent, that we call it as dilute solution. Example for dilute solution is small amount of salt, that is solute, is dissolved in large amount of water, that is solvent. Second classification, concentrated solutions. So concentrated solution means a solution in which more amount of salt or more amount of solute is dissolved in less amount of solvent, that we call it as concentrated solution. Example for concentrated solution is, here we are dissolving more salt, that is more amount of solute with small amount of solvent. That is more sugar or more salt is dissolved in less amount of water. The third classification is saturated solution. So what is the meaning of saturated solution? Maximum amount of solute in grams that can be dissolved in 100 grams of solvent at a particular temperature is called solubility of the solute, and such a solution is called saturated solution. So example for saturated solution is, if you keep adding sugar to water, a stage comes where sugar stops dissolving in water and it settles at the bottom. That we call it as saturated solution. Next, we are moving on to the fourth type, that is supersaturated solution. A solution containing more amount of solute than the required for saturation of a given amount of solvent at a particular temperature, that we call it as supersaturated solution. This type of solutions are highly unstable. It cannot stay in that state for a longer time unless you provide a particular extra temperature. Example, sometimes we prepare different types of sweets. To prepare sweets, we use sugar syrup, highly concentrated sugar syrup. So in order to maintain that, we need to maintain some temperature, particular temperature, and this stage is highly unstable. Next, concentration. So concentration we can express in two different ways. One is qualitative, the other one is quantitative. So here in qualitative we are not using any specified number here. Here these quantitative values we are calculating using some mathematical expression. So under quantitative we are going to study mass percentage, volume percentage, mass by volume percentage, ppm, that is parts per million, mole fraction, molarity, molality. Among all quantitative concentrations, this is very, very important for your board exams. Mole fraction. If you see your PYQs, previous year's question papers, they have asked questions based on mole fraction. So now we are going to study all the concentration terms one by one. First one is mass percentage. How can you define this mass percentage? Mass percentage of a component is equal to, it is the ratio of mass of the component in the solution in grams divided by total number of solution into 100. This is how we write the mathematical expression for mass percentage. For example, this type of questions they will ask you in your competitive exams. 20% W by W sugar solution in water. What is the meaning of this? 20 grams of sugar is present in 100 grams of solution. That means I can either write 20 grams of sugar present in 80 grams of water or 20 grams of sugar in 100 grams of water, 100 grams of solution. So this is very, very important. If I am writing only the solvent, I should write 80 grams. If I am writing solution, I should write 100 grams. These type of questions are very, very important for MCQs. Next, second concentration term is volume percentage. How can you define this? Volume percentage of a component V by V, which is equal to the ratio of volume of the component in ml divided by total volume of solution. Here volume is represented in ml into 100. So this is the mathematical expression to calculate volume percentage. So best example for this is when you take 20% alcohol solution in water. What is the meaning of this? We are taking 20 ml alcohol which is present in 100 ml of solution, or how I can write 20 ml of water plus 20 ml of alcohol plus 80 ml of water. Here specifically I am mentioning solvent, so I am writing 80 ml. Here I am writing solution, which is the combination of solute and solvent, so here I am writing 100 ml. So next, third concentration term, that is mass by volume percentage. So mass percentage by volume, mass, that is W, percentage by volume is represented by V. So mass percentage by volume is equal to, it is the ratio of mass of the solute, which is represented in grams, divided total volume of the solution in ml into 100. This is the mathematical expression which we use to calculate mass percentage by volume. Example, 20% of sugar solution in water. Mass by volume. Please concentrate here. 20% of sugar solution in water. That means 20 grams of sugar which is present in 100 ml of sugar solution. I am using a word called solution. So I am using here 100 ml. Next, fourth concentration term, parts per million, which is also represented by ppm. Parts per million is the ratio of number of parts of the component divided by total number of parts of all components of the solution multiplied by 100. So this is the mathematical expression which we use to represent parts by billion. Next, mole fraction. I told you this is very important. Many questions they have asked in your PYQs. Very important for board exam as well as your competitive exam. Mole fraction of component. Mole fraction is represented by a symbol called chi. So what is the name of this? Chi. Mole fraction of a component, that is chi, is equal to the ratio of number of moles of the component divided by total number of moles of all the components. So this is very important to solve many numericals in this chapter. Then if you assume Na is the number of moles of A, Nb is the number of moles of B, then chi A, what is chi A? Mole fraction of component A, chi B is mole fraction of component B. If I want to write the mole fraction of component A and component B, I am taking the help of these equations. Na is mole fraction of component A is equal to, it is the ratio of number of moles of A divided by number of moles of A plus number of moles of B. Similarly for mole fraction for the component B. Sometimes in problems you will be knowing the mole fraction of component A, you will be asked to calculate the other one, that is mole fraction of component B. So in that case, what you will do? You can make use of this equation. If mole fraction of component A is known, you can calculate the mole fraction of component B, because we know chi A plus chi B is equal to 1. This is also very important formula which you need to remember. Now we are going to take up the problems which is based on mole fraction. Let us consider the problem. If 4 moles of alcohol, 6 moles of water are mixed, Then calculate the mole fraction of each component. What is the data that they are giving in the question? 4 moles of alcohol, that is Na, component 1. Let us consider the component 1 as alcohol, and what is the value, how much they have given? Na is 4 moles. Nb, component 2, that is water, 6 moles of water. So they have given Na, Nb, and they are asking us to calculate mole fraction of A and mole fraction of B. So we all know the formula, mole fraction of alcohol, that is Ka is equal to Na by Na plus Nb. Na is given, Na is equal to 4, write down that value, divided by Na plus Nb. What is Na? 4, Nb 6. So 4 plus 6, if you solve this, you will get 0.4. Similarly, we can calculate the mole fraction of the second component, that is water. Mole fraction of water, that is Chi B, is equal to, same formula we are writing. Here we are calculating mole fraction of alcohol, so I have used A, Chi A. Here we are calculating the mole fraction of water, the other component, so we are specifically mentioning that as B. What is Nb here? Nb is 6. What is Na? Na is 4 plus what is Nb? 6. So if you solve this, you will get 0.6. So this is how we are going to calculate the mole fraction of components which is given in the question. So this is the second question which is based on mole fraction, and this is very important for your board exam. So now read the question. Calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. So they are giving only one component, that is ethylene glycol. If they are giving only one component, you can consider the other component as water. So what is given in the question? 20% of ethylene glycol is given. So 100 grams of solution contains what? 20 grams of ethylene glycol, 80 grams of the other component. They have not mentioned which is that other component, so I am taking that as water. So this is ethylene glycol and this is water, and this ethylene glycol I am considering it as component A, and the other one I am considering it as component B. So to calculate the mole fraction of A, we know the formula Chi A is equal to Na by Na plus Nb. What is Na? Number of moles of A. So to calculate mole fraction, first we need to calculate the number of moles. So we know the formula to calculate the number of moles, that is moles of A is equal to given mass by molar mass. Given mass is 20 grams. You can see here 20 grams of ethylene glycol they gave. So then molar mass. How to calculate the molar mass? We all know how to calculate the molar mass of ethylene glycol. What is the carbon mass number? 12 into how many carbon atoms are there? 2 plus mass number of hydrogen is 1 into 6 hydrogens plus mass number of oxygen is 16 into number of oxygens here is 2. So if you solve this, you will get 20 by 62. If you divide this 20 by 62, you will get 0.32 moles. Now we got the number of moles of A, that is ethylene glycol. So that is what I am writing here, Na, or number of moles of ethylene glycol is found to be 0.32 moles. Now similarly, we need to calculate the mole fraction of B. Chi B is equal to Nb divided by Na plus Nb. What is Nb here? Number of moles of component B. What is this B? That is nothing but water. Number of moles of B is calculated by using the formula given mass by molar mass. Given mass is 80 grams, because they are saying 20% of ethylene glycol, that is 20 grams of ethylene glycol is in 80 grams of water. So given mass is 80 grams, molar mass of water we know how to calculate. Hydrogen mass is 1. How many hydrogens they have given? 2. In plus 16 is the mass number of oxygen into only one oxygen is present, so 16 into 1, 80 by 18 if you divide, you will get number of moles of B is 4.6 moles. So that is what I am writing here. Number of moles of B or number of moles of water is equal to 4.6 moles. So now we came to know the values of Na and Nb, right? And we have a formula here because our intention is to calculate the mole fraction of A. So to calculate mole fraction of A, we need number of moles of A and number of moles of B. We just calculated the number of moles of ethylene glycol and water. Just substitute it here. Na is what? 0.32. 0.32 plus what is Nb? 4.6. Therefore, mole fraction of A is found out to be 0.0678. This should be your answer. Next, luckily in this question they are asking us to calculate only the mole fraction of A. Sometimes in question paper they will ask you to calculate the mole fraction of A and B. If that is the case, only thing is we know the mole fraction of A. If you know the mole fraction of A, we know how to calculate mole fraction of B using this formula. Chi A plus chi B equals to 1. So, write down the equation for chi B. Chi B is equal to 1 minus, send this chi A to that side. So, 1 minus chi A. Chi A value we just now found out. Substitute that chi A value here, 1 minus 0.0678. So, chi B value is found out to be 0.9322. But in this problem you can stop your answer at this stage itself because in the question they are asking us to calculate only the mole fraction of A. Next concentration term is molarity. So what is molarity? We already studied this definition in first PU. So molarity is the thing but number of moles of solute present in 1 liter of solution. Number of moles of solute which is present in 1 liter of solution. How to write the mathematical equation? Molarity is represented by capital M. Molarity is equal to number of moles of solute divided by volume of solution in liter. Make sure you need to take a volume here in liter itself. Now we want to solve one problem which is based on molarity. So calculate the molarity of the solution containing 5 grams of NaOH in 450 ml solution. So we know the formula to calculate the molarity. What is the formula to calculate molarity? Number of moles of solute by volume of solution which is taken in liter. So what is the data that we require? Number of moles of solute we need to know and volume of solution we need to know. So number of moles. What is the formula to calculate the number of moles? Given mass by molar mass. What is the given mass here? They are saying 5 grams of NaOH. 5 grams is dissolved in 5 grams of NaOH is dissolved here in 450 ml solution. So 5 grams of NaOH. What is the molar mass of NaOH? How are you going to calculate? NaOH. What is the mass number here? 22 into 1 plus oxygen 16. How many oxygen atoms you have? 1 plus mass of hydrogen is 1 into how many hydrogen atoms? 1. So 22 plus 16 plus 1. So molar mass of NaOH is 40 grams per mole. You will get around 39 point something. So we are rounding it off to 40 grams per mole. If you divide 5 by 40, you will get 0.125 moles. This is the number of moles of solute. Now we calculated the number of moles of solute. We need to know the volume of the solution in liter because we need to substitute the volume in liter itself in molarity formula. But they are giving the volume in 450 ml. So what we are doing? 450 ml by 1000 ml per liter. So you will get the volume in liter. So you can observe here. So number of moles of solute, that is 0.125 moles into volume of the solution is 450 by 1000 ml per liter. So if you send that 1000 to numerator, you will get 1000 ml per liter by 450 ml. If you substitute this, you will get 0.278 molar. This is molarity, so 0.278 m. So this is the last concentration term, which is nothing but molality, and this is represented by lower letter m, small letter m. Number of moles of solute present in 1 kg of solvent is nothing but molality. So what is the mathematical equation for molality? Molality small m is equal to number of moles of solute to mass of solvent which is taken in kg. This is the formula to calculate molality. So now let us take up one problem to understand this in detail. This is the problem which is based on molality. Calculate the molality of 25 grams of ethanoic acid in 50 grams of benzene. What is the data that they have given? Molar mass of ethanoic acid is 60 grams per mole. So we know the formula to calculate molality. Write down the formula first. Molality is nothing but number of moles of solute divided by mass of solvent in kg. So first one, what we need to calculate here? Number of moles of solute. So how to calculate the number of moles of solute? Given mass by molar mass. What is the given mass here? 2.5 grams of ethanoic acid, which is dissolved. What is the molar mass of this? 60 grams per mole. So divide these two, you will get the moles of solute. Now mass of solvent, which is a solvent we are using? Benzene. So mass of solvent is equal to given mass by molar mass. So given mass is 50 grams, molar mass is 1000 gram per kg. So if you divide these two, you will get 0.05 kg. So now you substitute the moles of solute as well as mass of solvent. You will get the answer as 0.834. This is how we want to solve the problems which is based on molality, molarity.